this video, I'm going to be explaining how to draw the structural formula and give the IUPAC name of molecular formulas for different alkanes. So looking at the first one, I have two CH3s, one CH, a CH2, a CH2, and a CH3. The best way to go about drawing out the structural formula, it pretty much gives you the way that it's drawn if you do it from left to right, if you look at it this way. So on your left you have two CH3 groups, and to the right of it there's a C group with just one hydrogen. When you're thinking of carbons, remember that to complete their octet, they like to have 4 different bonds. So if the carbon here is connected to 3 hydrogens, then that means it's only connected to 1 carbon. And since this carbon here only has 1 hydrogen, that means it's connected to 3 other carbons. So it makes sense to have your carbon drawn out with just 1 hydrogen. And then you add 2 CH3s onto it. CH3. So that got rid of this, and I got rid of that. So I have 2 carbons with 3 hydrogens and 1 carbon with 1 hydrogen. Now I'm just going to connect it to the CH2. So that part's done, and then I have another CH2. So you see, all I'm doing is I'm going from the left to the right. I'm drawing this structure out from left to right. So that was my other one. And finally, I'm left with the CH3. And a way you can check this is to just go back and see how many, like, I'm supposed to have 3 carbons in total that have 3 hydrogens. So 1, 2, 3. I'm supposed to have 1 that only has 1 hydrogen, and here it is, just 1. I have 2 that have 2 hydrogens, and here they are. So I know this is correct. So now I see that my longest chain has 5 carbons. So when I'm doing the IUPAC name, pent is the root that I'm going to use. So this is going to be a pentane. We do lowercase there. Pentane. And so just to show you, that's 1, 2, 3, 4, 5. That's my pentane. On my second carbon here, I have a methyl group added onto it. So this would be a 2. So when I'm going here, I have a methyl group on that pentane. And it has to be numbered. And you want to number it so that way the number is the lowest one when you're counting. So if I was counting this way, if I made this one my carbon 1, if I numbered it from right to left, that means this will be on the 4th one, but I can't write 4-methyl. I can't type this in because this would be bigger than 2. You always number it so that way it's the smallest carbon on the chain. So it's 2-methyl pentane. I have a methyl group connected to my second carbon on the 5-carbon chain, 2-methyl pentane. And that's how you draw the structural formula and give the IUPAC name for the first one. So now I'm just going to do the same thing for B. I'm going to go from left to right when I'm drawing it. So I see I have a carbon with 3 hydrogens. And that's connected to a C. So I got rid of these 2. Now I have 2 of these, 2 bromides. Now carbon doesn't have any hydrogens, so it must mean it's connected to these two bromines. And keep in mind that bromine only needs one bond to complete its octet, because all of these, like H, F, Br, Cl, I, all of these have 7 electrons in their outer shell. So all they need is 1 electron. They just need to have 1 bond to be stable to complete their octet. So done with the bromines, and now I'm left with is a CH3. And that's it. So this is the structural formula for this. Now when I'm doing the IUPAC name, again I'm going to look at my longest carbon chain, which is this here. So I know this is propane, because prop stands for 3. So propane. And now I'm going to look at what's connected to this chain. So I have 2 bromines. So bromo, and I have 2, so that's di. So dibromopropane. And now I just need to number them where they're at. So both of them are on the second carbon. So all I have to do is 2,2-dibromopropane. So that's the structural formula and the IUPAC name for B. So now looking at C, again I'm going to use the same strategy. I'm going to go from left to right. I have 2 CH3, so I'm going to draw my first one. And I'm going to look at what the first one's bonded to, which is a carbon with no hydrogens. And so since I have 2 of these, one of them is going to go on that carbon. So I have all of that done so far. And then I have a chlorine. Again, this is one of the ones where there's 7 electrons in its outer shell. It just needs 1 more. So if it bonds, it'll fill its shell. So Cl is connected to that carbon there because it doesn't have any hydrogens. And then I have a C bonded to a hydrogen. And what am I going to do? There we go. And then I just have 2 CH3 groups left. So CH3 and another CH3. So now I need to look at what is my longest carbon chain. Going from left to right. 1, 2, 3, 4. This is definitely my longest carbon chain here. 1, 2, 3, 4. So since my longest is 4, the root for that is bute. So this is a butane. I'm going to look at all of the groups that are connected to my longest chain. And I have a chlorine group, so that'll be chloro. And I have 2 methyl groups. So that'll be chloro, methyl. See how chloro comes before methyl? You put these in alphabetical order. And since I have 2 methyl groups, 2 methyl groups, I'll put di. So first I put them in alphabetical order, and then I'll add the di. Now I just need to show where they are on the carbon chain. So my chloro is on the second, so 2 chloro. And then I have a methyl on the second carbon and a methyl on the third carbon, so 2, 3 dimethyl butane. And I don't need that there. So 2 chloro, 2, 3 dimethyl butane. is the IUPAC name. And that finishes C. So the last one, it's very long, but I'm still going to use the same strategy. I'm going to go from left to right. First I'm going to draw my carbon with 3 hydrogens. I'm going to look at what they're bonded to, a carbon with 1 hydrogen. And I'll add my second carbon with 3 hydrogens. Eliminate that. And then I have 1 carbon with no hydrogen, so I'm just going to draw the carbon here. And what's connected to it is a methyl group here. It's all in parentheses, and there's 2, so I have 2 ethyl groups connected to that carbon there. So I'm going to do carbon and carbon, carbon and carbon. And all of those get hydrogens. And notice I'm still drawing it from left to right. I'm still going from left to right in this molecular formula as well. So then I have a carbon with 2 hydrogens. I have another carbon with 2 hydrogens. And then I have a carbon with 3 hydrogens. So that's going to finish my chain. So that's how you draw the structural formula for that one. And now I'm going to count how many there are, how many carbons. 1, 2, 3, 4, 5, 6. So this is a hexane. Because my longest chain has 6 carbons in it. And I'm going to look at what's connected to my chain. So I have ethyl groups and I have methyl groups. And I wrote ethyl first because in alphabetical order ethyl comes before methyl. I have 1 methyl group, so I don't need to add any prefixes to that, but I have 2 ethyl groups, so that's diethyl. And on my carbon chain, I have both the ethyls are on 3, so that's 3,3 diethyl, and my methyl's on 2. So 3,3 diethyl, 2 methyl hexane. And that is the structural formula and IUPAC name of all 4 of them. All you have to do is go from left to right, just draw it out the same way it's given as the molecular formula.